Dear students, grade 12. Today's video is about acid-base equilibrium and the calculations that we have studied in the first part. Okay, let's check our first example. The learning outcomes, what you're supposed to see in that video is how to calculate the concentration, how to use the pH to determine the concentration of hydrogen and hydroxide, and of course solve some problems. Okay, let's start easily first. Okay, for the first one, for each of the following equilibria, write the expression for the equilibrium constant, Kc, and state its units. Okay, so let's take the first one. Okay, for the first one, this is the equation that you have. And of course, as you know, Kc equal products, concentration of products, divided by concentration of reactants. Okay, so actually the reactants in this case, so let's do that. The products is N2O4, and here there's 1 mole, so it's N2O4. That's it. For the products, or for the reactants, I'm sorry, it's 2 moles of NO2. So this is the reactants, NO2 power of 2. So this is the Kc expression for that equation, which is equation 1. Now let's calculate the unit. As you can see here, just this is a concentration, so the unit for any concentration is mole dm minus 3. And there down you have mole dm minus 3, actually square. So one of these will go with the square, and this is what's left. Mole minus 1 dm cube. So this is the unit for Kc for that first reaction. Now let's try the second one. I think this one is easy. Let's try it. Okay, this is the products. Actually, this is the reactants. Okay, now let's try the Kc, which is products, concentration of products. This is the products, CH3, CH2, CO2, CH2, CH3, times the concentration of water, divided by the concentration of reactants. Okay, here for each of them we have 1 mole, so it's CH3, here's the curly arrow, CH2, CO2, H, times the concentration of CH3, CH2OH. This is the expression. Now let's calculate the unit. So here it's mole dm cube per dm cube times, again, mole per dm cube divided by, same thing, mole per dm cube times mole per dm cube. So for that reaction, the unit actually nothing. So let's check the other one. Okay, this is another example just to calculate the equilibrium. Okay, let's take a look at the question. Here you have pentachlorophosphate that gives trichlorophosphate plus chlorine. The equilibrium concentration of PCl5, PCl3, and Cl2 are 1.0, 0.205, 0.205 mole per diameter cube respectively. Calculate the Kc. Okay, so when you look at that equation, first thing you have to do is just write the rule, which is Kc equal concentration of products over the concentration of reactants. So the products in this case, this is the products, this is the reactants. So this is the products PCl3 and Cl2. First, let's check if this is balanced. Okay, one phosphorus, and 5 chlorine, 2 plus 3, 5. It's okay, it's balanced. So here is the reactants PCl5. Okay, now let's directly, because he's giving us the concentration. So all you have to do is just apply. Okay, so 1.0 belongs to PCl5. So, okay, I will put that. And for PCl3 and Cl2, 0. times 0.205. Okay, when you multiply that, divided by 1, it gives you that number, 0.04202025 mole per diameter cube. Okay, how did we know the unit? Easy. Now let's try. We have mole per diameter cube times mole per diameter cube divided by mole per diameter cube. So all you have left is mole per diameter cube for that reaction. This is the unit for Kc for that reaction. Now let's try another example. Okay, in this example, the reaction for formation of hydrogen iodide does not go to completion but reaches an equilibrium. Okay, so this is a reversible reaction. A mixture of 1.9 mole of H2 and 1 mole 0.9 of I2 iodine was prepared and allowed to reach equilibrium, in a closed vessel on 250 centimeter cube capacity. So this is volume. Okay, this is V. The resulting equilibrium mixture was found to contain 3 mole of H. I calculate the value of Kc. Now, this is interesting. Remember when we said Kc is about concentration, so the concentration of products divided by the concentration of reactants. Where is the concentration? In here there is concentration, there is no concentration, but he's giving you something else. In the question, he has given the number of moles for hydrogen and the number of moles for iodine. Also, he has given volume, which is 250 centimeter cube. While we're at it, just divide it by 1000 because it has to be in dm cube, so it's 0.250 dm cube. So how can we use that? For hydrogen, you have 1.9 mole. Same for iodine, 1.9 mole. Okay, remember that old rule, actually, that concentration equals N over V. So we have to use that to calculate the concentration. So for the concentration of hydrogen here, we will divide, where is that? Oh, this is my bad. This is 1.9 supposed to be. So the concentration of hydrogen will be 1.9. Oh, okay. So for hydrogen here, it's 1.9 divided by 0.250. So it gives 7.6 mole. This is the concentration of H. 7.6 mole per diameter cube. For iodine, same thing, because actually they have the same number of moles. Now for hydrogen iodide, it gave here 3 moles with the same volume, because actually these consumed, hydrogen and iodide consumed, and hydrogen iodide is formed. So it's 3 here divided by 0.25, and it gave 12 moles. Okay, so we use these numbers, these final numbers, which is the concentration, just for that. So in this case, Kc equal the concentration of HI, which is the product to the power of 2 divided by H2 times I2. What's wrong? Okay, now apply with the numbers. H2 actually is 12 square because it's the power of 2, it's 2 moles. Divided by 7.6 times 7.6. So there is your result. Okay, it's 2.4930. About the unit, here you have mole square dm minus 6 because it's power of 2. You have to square that too. And here you have mole dm cube times mole dm, minus 3, minus 3. So 1 mole goes with 1 mole. The other mole goes with the other mole. 1 dm goes here, and the other one goes here. So it's just 2.4930. Okay, check that. Okay, let's go back. Okay, this is, remember the Ka, the acid dissociation for weak acids. Okay, to start this calculation, we have to use a box which make it easier to solve that. This box is called ice table. Okay, you can call it as the ice table. Ice, this abbreviation is referring to I is for initial concentration. This is before reaction. This one is before reaction. And the change happens, this is C, and the equilibrium. Okay, let's read the problem. The acid dissociation constant Ka for benzoic acid is 6.3 times 10 power of minus 5. Find the pH of 0.35 molar, which is the concentration, solution of benzoic acid. Okay, so first of all, you have to write the equation and make sure it's balanced. Okay, check if it's balanced. Okay, so this is a weak acid. Most of organic acids are weak acids, so actually they partially ionize. So this is the proton, because acids are proton donors, and this is the anion. So in the table, we have the reactant and both of the products. So the initial concentration was actually only for the reactant, and this was 0. They were not formed. So the initial reaction only belonged to the reactants, which is 0.35 mole. And the initial for hydrogen and that ion, the negative ion, is 0 and 0, still not formed. The change happened after a while. Actually, it's minus X. So that reactant, actually the concentration have decreased with amount. We don't know that amount, so we'll refer it as it minus X. And this one increased with the same amount. So whatever went here actually just increased here. So at equilibrium, it's 0.35 minus X. And here's X and X. Okay, according to that equation, let's apply according to Ka equal, again, products over reactants. Okay, using the ice table, okay, in equilibrium, you just use X and X for H and the negative ion divided by the product. Okay, so it's X multiply X divided by 0.35. Okay, we said that it's minus 5 is the same because actually they reform again because it's weak acid. And here you have the Ka. Now, use the Ka to get X. So X just cross multiplies. So X squared equal that amount, 2.205. And then by taking the minus log of what you have now you have the pH of that acid. This is the end of our video, and hope it was useful. More to come. Thank you.